In this video, I will be demonstrating how to transform your data to match the target schema for the prompt migration process. This is intended to be a guiding example. Your experience will vary depending on the size and shape of your dataset. For this demonstration, I will be writing a small JavaScript app to extract data from a SQLite database and map it to the prompt target schema. Usually, the mapping of entities should be straightforward, but in some cases, there may not be an easy way to map your data onto the target schema, and you will have to make a decision on how you want to move forward. I'll be exploring some example scenarios to provide ideas on how to handle these edge cases. I'll start with a quick walkthrough of my environment. I'm using VS Code as my IDE, Node.js as my runtime, and we are using a SQLite database. If we take a look here, we can see a number of tables that have been filled with some mock data for the purposes of this demonstration. So to start, we're going to connect to our database by importing a library called Sequelize. Sequelize is a simple JavaScript library that we can use to run SQL queries against our database. Now that we have this set up, we can fetch some data. So we'll start by getting our domains. I'm going to do a simple select all from the domains table. And lastly, just need to pass in a bit of syntactic sugar here. And we can write that out to the console and take a look at our data. And we can see here that our domains have successfully been fetched from the database, and we can see the columns that are available here. We can confirm that by going to our database view, opening up that table, and seeing the columns available. So now we can map these to our departments. I'll do that by writing a map function on our domains. So what fields do we need to specify? Well, we can take a look at the prompt data spec, which I have here. I'll move it into the side, just so we get a better view. So we can see that for the departments entity, we have a number of fields to specify, the first being department ID. The description is an ID or GUID to identify the department. So this is something that we use within the migration tool for cross-entity references. This can be an ID from your existing database, or it can be something else. In our case, we don't have an ID field in our domains table. I do know that the name field is unique for all domains, so that would satisfy our entity constraint. However, I'm going to go with a GUID this time around, and I'll explain a little bit why in a moment. So to do that, I'm just going to import a library that I can use to generate a GUID. Moving down to the next field, we have name, also required. It's our department name, unique at the entity level. And we know that the name column on our domains table is unique at that level, so we can happily pass that through. The status is a bit trickier. Here we have 4 values that the status must confine to. If we take a look at our columns, we don't have a status, but we do have isActive and isHidden flags. So instead, what we can do is take a look at these flags and use a ternary operator. If the domain is active, we can assume it's in the general status. If the domain is hidden, then we can specify its status as hidden. Otherwise, we'll set the status as disabled. So now that the status is set, we have the description. We have a description in our database, so again, we can pass that one straight through. And lastly is the default review frequency. Now, we don't have this in our database. However, this is an optional field, so we can just omit this one and leave the default value of 36. So now let's write this out to the console and take a look at our map to data. So we can see here we now have a list of departments with the fields matching our prompt target schema, the correct GUIDs coming through, and our statuses are also populating correctly. Next, we'll take a look at the units, migrating these to sections. We'll start by fetching our units from the database. Much in the same way as before, just a simple select of the entire table. Then we'll map these into sections with a similar method to the departments. We create our new object, and let's scroll down to the sections part of the data spec, and we can see that the first field is section ID. Very similar to department ID, this is identifying the section, and we'll just use a GUID again. Now the reason we want to use a GUID here is because we could use the name like we considered for departments. However, I happen to know that in our units table we have some units with shared names. In this case, we have an inactive unit under the cardiology domain that shares a name with an active unit in the orthopedics domain. Now, the names can be shared amongst units as long as they're in different domains, and this is true in prompt as well. The unique constraint for section name is only at the parent level. However, the ID must be unique at the entity level, and so we cannot use the section name as an ID, and we use a GUID instead. We recommend doing this for all of the entities, either generating an ID or using an existing unique identifier for each of these entities so that they can be referenced correctly by the prompt migration tool. Next, we'll move on to the name. Like we said, it is unique already at the parent level, so we can pass this one straight through again. For the status, we have a similar situation to our departments, except this time our units columns does not include an isHidden column, so we will only be looking at isActive. If it is active, we set the status to general, otherwise we set the status to disabled. Next up is the department ID. This is a string that identifies the department to which this section belongs. We can see that we have a parent domain column on units, but as we saw before, this column has the name of the domain rather than its ID, and of course that makes sense because we are generating the ID at runtime. So in order to fetch that ID, we need to create a small lookup, and we can do that by using a reduce function. What this allows us to do is to set a key equal to the department name with a value of the department ID. Now down here, we can specify our department ID by using the department ID lookup and passing in the parent domain name. Finally, again, we have the default review frequency. Just like with our departments, we do not have a column for this in our database, so we're going to omit that field and allow it to populate with the default value. Now let's console log our sections and see what it looks like. Great, so you can see that our sections have been mapped correctly. These field names match the data spec that we can see here, and the department IDs have correctly flowed through, and we can see here these two department IDs are the same, and so they're referencing the same department. Lastly, we're going to move on to policy types, migrating these to document types. So I'll start by fetching them from the database. Once again, a simple SQL select query. Now we'll be mapping these into document types. So let's find that in our data spec. And here we are. So document types has a few fields. So we start with document type ID, which will be a GUID, followed by name. If we take a look at our policy types table, we can see that we do indeed have a name column. However, there is a constraint on this column in the prompt migration schema that the maximum length of the string has to be 50 characters. So what we have to do is take the name and simply take a slice of that string from 0 to 50. Lastly, we have the order. This is the positional index of the document type as displayed in the document types list. This is within the prompt application itself. So this is an integer. We don't have any column representing the order within our database. So what I'll do is take the index argument in this map function, and we'll simply pass that through. Now we can take a look at our document types and see what it looks like. And here we can see all of our document types have flowed through with the order numbers increasing from 0 right through to 19. Now you will have to map each entity into the data file, but for this demonstration, I'm just going to be doing a partial export. So to do so, let's create our final output object. And that's just going to be a simple object with the following keys that you can find in the prompt data spec. And to write this to a file, I'm going to just import the fs library, and we will write this to disk. Now if we run this, we can see we've generated our output.json, and if I pretty print this for us, we can see our list of departments. Oh, it looks like we might have a small error here. Yes, just need to supply an empty object as our initial value here. So we'll run that one more time, and we should see there we go, much better. Now we can see our complete output for each of the entities, departments, sections, and document types that we generated our mapping for. That concludes this video. If you have any more questions about the prompt migration schema, please consult the prompt help docs at help.prompt.org.au.